In the last video, we talked about the standard form for a circle and the general form for a circle. And we go from standard form to the general form by multiplying everything out and moving everything over to one side. We go from the general form to the standard form by completing the square. But I've got a problem up here, and I've copied the directions as they appear in your homework, because I just sort of wanted to discuss them. So we're given an equation, x squared plus y squared plus 2x minus 4y plus 5 equals 0. And we're asked to write that in this form, x minus h squared plus y minus k squared equals c. Now that's almost, but not quite, the standard form for a circle. The difference is r squared is standing for the radius squared. By definition, the radius is a positive number, and of course a positive number squared is positive. Okay. Here, the left-hand side matches. This would be what I get if I complete the square, but then it's just set equal to a number c. Okay. If c is a positive number, then I can say c is the radius squared, and I've got a circle. And that's what happened in the example we worked through at the end of the last video. Okay. But c could be 0 or a negative number. So there's nothing that says when I complete the square and move the number, the constant, over to the right-hand side that it has to be a positive constant. And if it's not a positive constant, then it doesn't match the standard form for a circle. It's not going to give me a circle. If c is 0 or c is negative, we call those a degenerate case. So the directions say if the equation represents a circle, that would be if c is a positive number. Okay. Then we just identify the center and the radius. But if the equation is a degenerate case, that would be if c is less than or equal to 0, then we're supposed to just give the solution set, because then we're not getting a circle. Okay. Let's just take a look at what could happen. Okay. If c is bigger than 0, we said we're going to get a circle of radius root c. And of course the center would be at hk. If c is equal to 0, okay. Well, if I take a look at this left-hand side, it's a square plus a square. Okay. The smallest this term could be would be 0, and the smallest this second term could be is also 0. So the smallest the left-hand side could be is 0. So it is possible to have this equal to 0, but the only way that would be true is if this term was 0, so x was h, and this term was 0, so y was k. So if c is equal to 0, we're going to get a single point as our solution, and it would be the point hk. Now again, the book is giving things in set notation, so they would say it's the set consisting of that single point. I'm not concerned that you use set notation. I'm concerned that you give me the solutions. But the solutions, notice, because this is an equation in 2 variables, the solutions are not numbers. The solutions are points or ordered pairs. So we would get a single point in the xy plane. Some books would call this situation a degenerate circle. It's like a circle of radius 0. Okay? Our book calls this a degenerate case. It doesn't refer to a point as a degenerate circle. It says in order to have a legitimate circle, you've got to have a positive radius. Just want to let you know that the vocabulary varies a little bit. Our book is saying a point doesn't count as a circle. Some books would say a point counts as a degenerate circle, a circle of radius 0. Okay, and let's see what happens if c is less than 0. Well, that's not possible, because we just said the smallest this left-hand side could be is 0. It can't be negative. I can't add 2 non-negative things and get a negative number. So if c is less than 0, I would have no solution, and I'm fine with you writing that in words. If you were to give that as a solution set, it would be the empty set, which you can write one of 2 ways, either as these braces that are literally empty, or as this thing that looks like 0 with a slash through it. Okay, have an equation like this, in this form, I can always complete the square to get it into this form. I do want to point out this is a lowercase c. I'm not crazy about this choice because in standard form they had a capital C for the constant that showed up in standard form for a circle. Well, this is not the same as that capital C. This is just what we get when we complete the square. And then I have to look. If it's a positive number, I've got a circle. If it's 0, I've got a single point. And if it's negative, I've got no solution. Okay, so let's just work through this and see what we have. So I like to just rearrange it. I'm going to put my x's together. So x squared plus 2x, and I'm going to leave a space to add a number there. Okay, plus y squared minus 4y, and I'm going to leave a space to add a number there, is equal to negative 5. I'm just going to bump the number over to the other side. And of course, I'm hoping to add a number here, which I would also add to this side. And I'm hoping to add a number here, which I would also add over to this side. Okay, I like to just have written down x plus a number squared, and I just call it d because I don't know what it is. That's x plus d times x plus d. That's x squared plus 2dx plus d squared. Okay, so if this part is going to match this formula, I need 1x squared, and I have 1x squared. The number of x's that I have is supposed to be 2d. The number that I have is 2. So d would have to be 1, and that means that d squared would equal 1. So I'm going to add 1 on the left side, and I'll add 1 on the right side. Okay. Then, when I look at the y's, if I'm trying to complete the square here, I would need to have 1 copy of y squared, and I do. The number of y's I need is 2d. The number of y's I have is negative 4. So d would be negative 2. That makes d squared 4. So I'm going to add 4 on both sides. Once I've done that, both of these terms now factor. So this is going to be x plus our d here was 1, so x plus 1 squared, plus this will be y plus our d here was negative 2, so that's y minus 2 quantity squared. Negative 5 plus 1 plus 4 is 0. So when we completed the square, the number we got on the right was 0. That's one of our degenerate cases. That's the degenerate case, though, where we do, in fact, get a solution. I could make the left-hand side 0 if I made x negative 1 and y 2. So I'm getting a single point as my solution, and that point would be negative 1, 2. Okay. Again, if you want to put that in set braces, I'm totally fine with that, but I'm not going to insist that you give me set notation. I just want a description of that as the solution.